Alright, it's Halloween and that means we're gonna get a bunch of candy. And for me, my favorite candy is circus peanuts. And usually I get circus peanuts 33% of the time. So, one time, I was going trick-or-treating and I got some other candy, which I really don't care about. And then sometimes I was getting circus peanuts, like I said, my absolute favorite candy. And actually, one instance, I got not one, not two, not three, not four, but 5 circus peanuts in a row. If I didn't say it already, I was super excited because I love circus peanuts. Well, that's pretty crazy, Cal, don't you think?
That was pretty normal, to be honest. Pencil, I'm not that surprised.
Well, compared to the usual 33%, I think that's pretty unusual.
Well, I think that you're full of it, like always.
Okay then, I'll just prove you wrong then. Alright guys, let's pull out our learning cards.
Well, what is a simulation? A simulation is an imitation of chance behavior. The first step is to state the question. The second step of the process is to plan it out. The third step is to do the simulation or trials. And finally, we conclude and answer the question.
So, like we said earlier, the first step in a simulation was to state the question. For us, our question was, are people giving out more circus peanuts than the usual 33% do? So after we figure out our question, we list out any assumptions we may have. And then after that, any variables that we were already given, we'll go ahead and put these out and they will be independents. And in this case, the usual 33% of circus peanuts was our independent.
The second step in the process is the planning of the simulation. What we do here is assign digits on the die or digits in a table or calculator. In this case, we will assign 1 and 2 to being circus peanuts on the die. We will roll the die 5 times and record if we get the circus peanuts values 5 times in a row or not. We will then repeat this process 19 more times and tally up all of the data.
The third step in the simulation is to actually do the simulation and tally up our results. So, based on our simulation, 5 out of the 20 times we actually got circus peanuts 5 times in a row. Pretty ironic. For the other 15 simulation runs, we did not get circus peanuts 5 times in a row. So that could have been 4 times in a row, and then we got other candy.
The final step of the simulation process is to conclude and answer the question. Based on our data, getting 5 in a row was not unusual. Our simulation results were not enough evidence to prove unusualness. Our simulation results were enough to prove it was unusual. Pencil, you are once again wrong, and I was right.
Well, shut the up, you piece of calculator.
Well, you know what, Pencil? I'm this close to breaking you in pieces, you piece of...